Hi everyone, Assalamualaikum. In this video, we will continue our discussion of separable equation. Right? Now we continue with example 3 from miscellaneous exercises. Solve the differential equation 8xy over x plus 2 times y plus 2 dy over dx minus y squared plus 4 equals to 0. Right? Alright, every time when we solve separable equation, first step, we need to separating variables x and y. Left hand side we write fy dy and right hand side we write fx dx. From the given question, okay, to separate variable x and variable y, we can follow Boltzmann's rule. Okay, if we want to solve the mathematical operation, we need to solve in bracket, exponent or root, division, and then multiplication, and then addition or subtraction. Okay, but now we want to separate. Okay, if we want to separate, okay, we need to follow subtraction first, and then addition, multiplication or division, and then of bracket. Alright. So now we want to separate. So we separate subtraction and addition first. Okay. So from here, okay, we can move minus y squared plus 4. Okay, we move to right hand side. So we have positive y squared minus 4. Alright. And actually, y squared minus 4 can be write into the form of bracket y squared minus 4 over 1. Okay, from here, all mathematical operation is multiplication or division. Alright. So from here, we can move variable x and variable y. Okay. Now, our mission is we want to write left hand side in terms of variable y and dy, and right hand side we want to write variable x and dx. Okay. So from here, okay, we have dx on the left hand side. So we want to move to right hand side. Okay. So dx here is in denominator. Okay. So when we move to right hand side, it become multiplication. Okay. And then x here, okay, is numerator. So when we move to right hand side, it become denominator. Okay, or division. Okay. And then from x plus 2, okay, x plus 2 is in denominator. So when we move to right hand side, it become numerator. Okay, so now all from right hand side is variable x, okay, and dx. Okay, so we need to move variable y to left hand side. Okay, so from y squared minus 4, okay, this is in numerator. So variable y, we want to move to left hand side. So when we move numerator y squared minus 4 to left hand side, so we have denominator y squared minus 4. Okay, here. Okay. So now we complete separating variable x and variable y. Okay, left hand side we have variable y and dy, and right hand side we have variable x and dx. Alright. And then from here, okay, we can integrate. Okay, but if we notice that this quadratic is reducible, so we can factorize it first. Okay. So from y squared minus 4, okay, we can write y plus 2 times y minus 2. Okay, we factorize it. Okay. And then from here, okay, we have y plus 2 times y plus 2. Okay. So we can write y plus 2 bracket squared. Okay. Alright, from here, we can continue with step 2, integrating both sides. Alright. So from step 1, okay, we have 8y over y plus 2 bracket squared times y minus 2 dy equals to x plus 2 over x dx. So when we integrate both sides, we just put integration sign for both sides. Alright? And then we can name as equation 1. Alright? Right, from the previous slide, we stop until here. Okay, we put integration sign for both sides and then we name as equation 1. Right, and after that, we integrate both sides. Okay, so we integrate left hand side first. Okay, when we integrate left hand side, okay, integration of 8y over y plus 2 squared times y minus 2 dy, we need to use partial fractions. Right. So, from 8y over y plus 2 bracket squared times y minus 2, we need to write into the form of sum of partial fraction. Right? So, now we have repeated linear factors, yeah, which is y plus 2 squared. Okay? So, we need to write the denominator, the first denominator, y plus 2, the power of 1. Okay? And then followed by plus fraction with denominator y plus 2 squared. Okay, from here. Okay, from repeated linear factor here. Right? And then we have factor y minus 2. So we put plus fraction with denominator y minus 2. Alright? And then from the first fraction, in bracket is linear factor. So, if we have denominator with linear factor, numerator should be constant. Okay. So, we put A. Okay. And then, from the second fraction, we have, in bracket, we have y plus 2, which is linear factor. No need to expand. We just refer the factor inside bracket only. Okay. So, the factor inside bracket is linear. So, numerator should be constant. So, we put B here. Okay. And then, from the third fraction, we have denominator y minus 2, which is linear factor. So, we put constant C, okay, on the numerator. Okay. And then, we name as equation 2. Okay. And after that, okay, we standardize the denominator. Okay. And the denominator for right hand side must exactly equals to the denominator on left hand side. Alright. So from left hand side, 8y over y plus 2 bracket squared times y minus 2. Okay. We write a fraction with same denominator to the left hand side. Alright. Alright, now, okay, for numerator A here, okay, to write into the form of denominator y plus 2 bracket squared times y minus 1. Okay, now we have denominator of A is y plus 2. So, to write into the form of denominator y plus 2 bracket squared times y minus 2, we need to multiply by y plus 2 times y minus 2. Okay, so that when we simplify, okay, we have y plus 2 bracket squared times y minus 2. Okay, from here. Okay, and when we multiply denominator with y plus 2 times y minus 2, we should multiply numerator with the same factor. Okay, so that if numerator and denominator exactly same, so we can simplify, so it is actually equals to 1. So it doesn't change the original value or the original function. Okay. So now after we multiply A by y plus 2 times y minus 2, so we get A times y plus 2, y minus 2 here with denominator y plus 2 bracket squared times y minus 2. Okay. So we can write A times y plus 2 times y minus 2 because we want denominator y plus 2 bracket squared over y plus 2 bracket squared times y minus 2. Alright. And then to standardize denominator b, okay, from b we have denominator with y plus 2 bracket squared. So to write into the form of denominator y plus 2 bracket squared times y minus 2, we need to multiply numerator and denominator by y minus 2, okay, with in denominator and y minus 2 in numerator, okay. Numerator and denominator should be same, okay. And then after we multiply, so we have b times y minus 2 with denominator y plus 2 bracket squared times y minus 2. Okay. And then to standardize denominator c into the form of y plus 2 bracket squared times y minus 2, we need to multiply numerator and denominator by y plus 2 bracket squared. Okay, so that when we simplify denominator here, we get back y plus 2 bracket squared times y minus 2. And see now, after we multiply numerator by y plus 2 bracket squared, so we have c times y plus 2 bracket squared. Okay, with denominator y plus 2 bracket squared times y minus 2. Alright. So now we have denominator from right hand side and left hand side exactly equal. Yeah. Okay, since the denominator of both sides are equal, so we can say that the numerator for both sides also equals. So we can write the numerator 8y equals to the numerator on the right hand side, which is a times y plus 2 times y minus 2 plus b times y minus 2 plus c times y plus 2 bracket squared. And then we name as equation 3. Alright. From the previous slide, we stop until equation 3. Okay, where we equate numerator for both sides. Okay, and after that, we need to find the values of constant a, b, and c. To find the values of a, b, and c, okay, which is 3 constants, we need to substitute 3 values of y into equation 3. Okay. Okay, first, we substitute y equals to negative 2 into equation 3. And then we substitute y equals to 2 into equation 3. And then we substitute y equals to 0 or any value except y equals to negative 2 and y equals to 2. We substitute into equation 3. Okay, why we substitute y equals to negative 2 into equation 3? Because when we equate the factor y plus 2 equals to 0, so we get y equals to negative 2. Okay, so when the factor is 0, so it is easy to find the values of the given constants. Okay, why we choose y equals to 2? Okay, because we equate y minus 2 equals to 0, so we have y equals to 2. And after that, no more linear factors. Okay, so we can take any values of y except negative 2 and 2. Okay, and we choose the easiest value of y such as 0. Okay, we substitute into 3. Okay, alright, first, after we substitute y equals to negative 2 into equation 3, so we have 8 times negative 2. And when we substitute negative 2 into here, so we have 0 here. Okay, because we equate y plus 2 equals to 0, then we get y equals to negative 2. So when we substitute back into factor y plus 2, so we have 0 here. So 0 times any values will equals to 0. And then plus b, we replace y by negative 2. So we have negative 2 minus 2. And then plus 0. Why 0? Because when we substitute negative 2 into here, so we get 0 here. So 0 times any values will equals to 0. Alright. So after that, we simplify. So we have negative 16 equals to negative 4b and b equals to 4. Alright. And then we substitute y equals to 2 into equation 3. Okay, why we choose y equals to 2? Because when we equate the second factor to 0, we get y equals to 2. Alright, so when we substitute y equals to 2 into equation 3 here, so we have y times 2 equals to, okay, we have factor y minus 2. Okay, when we equate to 0, we get y equals to 2. So when we substitute back here, so we have 2 times 2 equals to 0. And 0 times any values will equals to 0. Alright, and then plus, okay, now we still have factor y minus 2. So when we substitute 2 into y here, so we get 0. So 0 times b equals to 0. Alright, and then plus c, and then we substitute 2 into y here. So we have 2 plus 2 squared. Okay, times c here. Then we simplify. So we have 16 equals to 4 squared is 16. So we have 16c. So c equals to 1. Alright. And then there is no more linear factors here. Okay, so we can choose any values of y to substitute into equation 3. Okay, but we better choose the easiest value. Okay, such as 0. So we substitute 0 into whatever y in equation 3 here. So we get 8 times 0 plus a, and then 0 plus 2 is 2. 0 minus 2 is negative 2 plus b. 0 minus 2 is negative 2 plus c. 0 plus 2 is 2 and then squared. Okay, so after we simplify, we have 0 equals to negative 4a minus 2b plus 4c. Okay, and then we can divide by 2. Okay, so we have 0 divided by 2 still 0 equals to negative 2a minus b plus 2c. Okay, and then we can replace b, okay, equals to 4 and c equals to 1. We substitute here. So we have 0 equals to negative 2a minus 4 plus 2 times 1. Okay, so we have 2a equals to negative 2 and a equals to negative 1. Alright, after we find the values of a, b, and c, okay, we substitute the values of a, b, and c into equation 2. Okay, we recall back equation 2. Okay, equation 2 from the previous slide is 8y equals to 1 plus 2 bracket squared times y minus 2 equals to a over y plus 2 plus b over y plus 2 squared plus c over y minus 2. Okay, so now we replace a equals to negative 1, b equals to 4, and c equals to 1. So we get 8y over y plus 2 squared times y minus 2 equals to, we replace a by negative 1, so we have negative 1 over y plus 2, plus we replace b equals to 4, so we have 4 over y plus 2 squared, plus c we replace by 1, so we have 1 over y minus 2. Okay, now we done split this fraction into the sum of partial fraction. Alright? Okay, from the previous slide, we express 8y over y plus 2 bracket squared times y minus 2 into the sum of partial fraction negative 1 over y plus 2 plus 4 over y plus 2 squared plus 1 over y minus 2. And after that, we can integrate one by one with respect to y. Okay, so we integrate 8y over y plus 2 squared times y minus 2 dy. It will equals to, we move out negative sign here. So we have integration of 1 over y plus 2 dy plus we move out constant 4. So we have 4 integration of 1 over y plus 2 squared dy and then plus integration of 1 over y minus 2 dy. So we integrate one by one because in between is plus sign. Alright. Okay, and then from 1 over y plus 2, we can move up using the properties of indices. So we can write y plus 2 the power of negative 1. And then for y 1 over y plus 2 squared, we can move up using properties of indices. So we have y plus 2 bracket the power of negative 2. And from 1 over y minus 2, we can move up using the properties of indices. So we can write y minus 2 the power of negative 1. Alright? Alright, and then the integration of 8y over y plus 2 squared times y minus 2 dy will equals to, okay? So to integrate 1 over y plus 2 dy, okay? And to integrate 1 over y minus 2 dy, we can use either three methods here. Okay, number one, when we differentiate the denominator and it becomes a numerator. When we differentiate denominator here is y plus 2. And after we differentiate y plus 2 with respect to variable y, so we have 1. So when we differentiate denominator, it becomes a numerator. Okay, numerator now is 1. So the answer is ln denominator. Okay. Or we can use formula integration of ax plus b the power of negative 1. So we move up here. Okay, we move y plus 2 to numerator. So we have y plus 2 bracket the power of negative 1. So when we have the power of negative 1, we can use this formula. Okay, and this is the answer when the power is negative 1. Okay, for integration of y minus 2 the power of negative 1 dy, we use the same technique. Okay, for integration of 1 over y plus 2 dy and 1 over y minus 2 dy, we use the same technique from here. Okay, or step 3, we can use u substitution. Means that to integrate 1 over y plus 2 dy, we use u equals to y plus 2. And to integrate 1 over y minus 2 dy, we choose u equals to y minus 2. Okay, there are three methods to evaluate this integral. Alright? So, when we integrate 1 over y plus 2 dy from either method 1, method 2, or method 3, okay, we have negative ln y plus 2. Okay, from here, 1 over a means 1 coefficient of y, okay, and then ln ay plus b. Now our a is coefficient of y is 1 plus b equals to 2. So we have this, negative ln y plus 2. Okay, when we integrate 1 over y plus 2 dy. Okay, and then when we integrate 1 over y minus 2 dy, we have ln y minus 2. Okay, you can try this technique, okay, by yourself. Alright. So when we integrate integration of 1 over y minus 2 dy, we get this. Okay, and then to evaluate integration of y plus 2 the power of negative 2, okay, we can use either method 1 or method 2. Alright. So when we choose the first method, okay, so we can write, we still have constant 4 in front and then 1 over 1 because 1 over a. A is coefficient of y. Okay, so 1 over 1 times, and then we write bracket ay plus b means y plus 2, and then the power of n plus 1. Okay, our n, original n equals to negative 2. So we plus 1, so we have negative 1. Then over n plus 1, n is negative 2 plus 1 equals to negative 1 here. Alright? Or we can use u substitution. Our u equals to y plus 2. You can try it by yourself. Right? So after we integrate y plus 2, the power of negative 2 dx, we have this. Okay? And after that, we can simplify. So we have negative ln y plus 2, and then 4 over negative 1. So we have negative 4, and then we can move down the power of negative 1. We move to denominator. So we have y plus 2, the power of 1. So no need to write the power of 1. Okay, and then plus ln y minus 2, and then plus c. Alright? Alright, from the previous slide, okay, we done integrate left hand side. Okay, and when we integrate left hand side, which is integration of 8y over y plus 2 squared times y minus 2 dy, it is equals to negative ln modulus y plus 2 minus 4 over y plus 2 plus ln y minus 2 plus c. Okay, so after we done integrate left hand side, okay, we can continue integrate right hand side. Okay, the function on the right hand side is integration of x plus 2 over x dx. Okay, to integrate x plus 2 over x dx, we separating the fractions because we have denominator with single term. Alright, so from integration of x plus 2 over x dx, after we separate the fraction, so we have integration of x over x plus 2 over x dx, right? And after that, we simplify. So x over x is 1, okay, and then plus 2 over x dx. And then integration of 1 plus, we can write 2 times 1 over x, okay, for 2 over x here, okay. And then we integrate 1 with respect to x, it becomes x. And then plus, we still put the constant 2 in front here. And then we integrate 1 over x, we have ln x. And after that, we put plus c at the back, right? So until here, we done integrate the function on the right hand side, okay? So after that, we substitute the answer when we integrate the function on the left hand side and right hand side into equation 1. We recall back equation 1. Okay, this is equation 1 in the previous slide, right? So after we substitute left hand side and right hand side into equation 1, so we have the general solution. Okay, so the general solution is, okay, from equation 1 here, we substitute the answer when we integrate the function on the left hand side, which is negative ln modulus y plus 2 minus 4 over y plus 2 plus ln y minus 2, okay, and then equals to, we substitute the function on the right hand side after we integrate. So the answer is x plus 2 ln x plus c. We just put plus c on one side only. Alright? So this is the final answer after we integrating both sides. Okay? From the given question, the initial condition is not given. Okay? So we no need to find the value of c. Okay, so we just find the general solution in terms of C here. Alright, so this is the final answer. Alright, we no need to applying the given initial condition because the initial condition is not given. Alright. Coming up next, more examples for separable equation. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.